Today I'd like to take a look at the first section of probability, so go ahead and open up your study guides to probability 1. Now let's begin with the definition of probability. Probability is basically a measure or estimation of how likely it is that an event will happen or that a statement is true. Probabilities are given a value between 0, that is 0% chance, or will not happen, and 1, 100% chance, or will happen. So we assign probabilities of values between 0 and 1. We can also assign them percentages from 0% to 100%. 0% once again is a chance that it won't occur, and 100% chance is a certain chance that it will happen. The higher the degree of probability, the more likely the event is to occur, or in the long run, the greater the number of times such event is expected to occur. So once again, probability represents a degree, basically, or a measure to how likely it is that an event will occur, or in the long run, the number of times such event is expected to occur. We will continue to use the fundamental principle of counting we learned earlier to help us define our probabilities. Now let's begin with the definition of sample space. To understand probability, we need to define some important terms, and the first one is sample space. Now in probability, a sample space is the collection of all possible outcomes of a chance experiment. So when we have a chance experiment set up, a sample space represents all possible outcomes that could occur based on this chance experiment. Let's take a look at some sample space examples. Suppose we roll a fair die. The sample space would include a list of all possible outcomes. That is, our sample space, S, could be equal to 1, 2, 3, 4, 5, or 6. So there's 6 possible outcomes on the roll of a die, and the sample space is represented by each one of those possible outcomes. Many times we denote sample space with a capital S, and we list the possible outcomes of the sample space in a set of braces. Now let's suppose we toss a fair coin twice. What is the possible sample space? Now recall, one coin could result in heads or tails. So there's 2 possible outcomes for each coin. So if we toss that fair coin twice, the possible sample space could be I get a head on the first toss, a head on the second toss. Perhaps we get a tail on the first toss, a tail on the second toss. Maybe we get a head on the first toss, a tail on the second toss, or we could possibly get a tail on the first toss and a head on the second toss. So our sample space would be denoted by the 4 possible outcomes that could occur when tossing a fair coin twice. Now this leads us to the definition of event space. In addition to sample space, we need to define event space when dealing with probabilities. Now an event space is any collection of outcomes from the sample space. The event space is always a subset of the sample space. So an event space is basically defined by our event or a probability and what we want to achieve out of the entire sample space. So the event space is a subset of the sample space itself. Suppose we roll a fair die. What is the event space for rolling a prime number? Now once again, the event space is a subset of the entire sample space. We've narrowed our sample space down now in this particular event space by looking at the event space for rolling a prime number. So my event space here would be the possible rolls of 2, 3, or 5, since these are the only prime numbers in my sample space. Many times we denote event space with a capital E, and we list the possible outcomes of the event space in a set of braces. Suppose we toss a fair coin twice. What is the event space for tossing at least one tail? So to get at least one tail means I could flip one tail, or I could flip 2 tails on a toss of a fair coin twice. So I could get tail tail, I could get head tail.